Hello everyone and welcome to my video on dividing complex numbers, rationalizing the denominator. So here we're going to go over what to do when we're dividing a real or a complex number by a complex number. And what we're going to do is we're going to go and try our best to get I out of the denominator. So our goal here is not necessarily to divide the whole thing, it's to simplify it by getting I out of the denominator. So what we need to do in order to do this is remember that I is the square root of -1. But more importantly, that means that I squared is -1. So in order to get I out of the denominator, we're going to need to turn it into an I squared, right? Make all the I's an I squared and it'll become -1 and no longer have that I in the denominator. So here, I'm going to multiply the denominator by I, but I can't change what I have here. I can't change 2 over 8i, so the only way I can leave it the same is if I multiply by 1. But in order for this to be 1, that means both the numerator and denominator are the same. So whatever I multiply the bottom by, I also have to multiply the top by. So here I'm going to multiply 2 over 8i by a fraction of I over I. In order to do this, you're going to multiply straight across. So 2 times I is 2i, and 8i times I is 8i squared. All right, so then once we do this, we need to again remember that I squared is -1. So this becomes 2i over 8, and instead of I squared, that's going to become -1. And then I can simplify this. That -1 is going to be multiplied by that 8, so we get 2i over -8. And then there's a couple things. One, we don't want to leave the negative in the denominator. So you can either move that negative out front or move it into the numerator. It doesn't matter, but it's bad form to leave it in the bottom. So it's got to go somewhere. If both the top and the bottom were negative, then they would have canceled and I wouldn't have to worry about it. But in this case, I'll just move it out front. And then what you also need to realize is that you're going to simplify this fraction as if it were a regular fraction. And if you wanted to, you can even take this I and move it out after the fraction. Right? So if you want to have it after, you can, or up top, that's okay. In this case, 2 and 8 both have a common factor of 2, so I'm going to divide that 2 out of here and take out a factor of 2 over 2. So that's going to give me -1 over 4i. All right, so I'm going to take that I, I'm going to move it outside, and then that's going to leave me with a 1 in the top because 2 divided by 2 is 1, and then 4 in the bottom because 8 divided by 2 is 4. Again, you could write it a couple different ways. You could write that negative and the I in the top to have it look like -I over 4. You might see it a couple different ways depending on how you end up writing it, but they're all equivalent to each other. All right, so same thing here. In the bottom is just a pure imaginary number, right? So imaginary or complex numbers are going to be in the form either a plus bi or just bi. And in this case, we're doing problems where there's just the bi. There's no other number in front, a real number being added or subtracted to this. All right, so that changes the process a little bit. So when we see just a pure imaginary number in the bottom or something like bi, that's when we're again going to multiply the top and the bottom by I. It'll get more complicated when that denominator is an actual complex number, but for now, we're just going to multiply that top and bottom by I. And that'll give me 6i over -4i squared. Again, I squared is -1, so that becomes -4 times -1. And the two negatives multiply to a +4. And then 6 and 4 can both be divided by 2. 6 divided by 2 is 3i. 4 divided by 2 is 2. So here we get the final answer of 3i over 2. And then the last one we're going to do that has just a pure imaginary denominator. Again here, the bottom is I. or not an actual complex, pure imaginary, right? It doesn't have that real number in the front of it. So again, I'm just multiplying everything by I, both top and the bottom. On the bottom, negative I times I is negative I squared. On the top, however, we're going to have to distribute this I to both negative 1 and plus 8I. So when we distribute this, it becomes negative I plus 8I squared. Okay, so our next step is to turn those I squareds into a negative 1. Okay, so we're going to turn those I squareds into a negative 1. So that becomes negative I plus 8 times negative 1 over negative 1. So what I did here was anywhere I had an I squared, I just replaced it with a negative 1 because they're equivalent to each other. And now I need to simplify. So it gives me negative I minus 8 divided by a positive 1. So right off the bat, dividing anything by 1 doesn't change it, so I can get rid of the denominator here to get negative I minus 8. But when you're doing complex numbers, you want the imaginary portion to be in the back. So I'm going to take this negative 8, that's going to go in the front, and then the negative I is going to switch places and go in the end. So here, this simplifies to negative 8 minus I.